Alright, so in this video we're going to look at Bluetooth low energy hacking, and the device we're going to look at right now is just this Govee Wi-Fi smart device. It looks at the temperature and humidity and gives all this data to the mobile app that it comes with. So we're going to look at trying to exploit this device's Bluetooth, because you can set it to use Bluetooth only, and we will be able to remotely control it without authorization or authentication. And we're also going to look at the data that it leaks through Bluetooth when you want to set up the Wi-Fi for this device. So we're just going to need a few tools for this attack. This right here is just a Bluetooth adapter. This is what I personally use when I'm attacking Bluetooth. If you have a virtual machine, you can plug this into your computer and hook it up to your virtual machine, and it will allow it to interface with Bluetooth devices. It can help us scan Bluetooth devices and communicate with them. So this is an integral part of the Bluetooth hacking. Then next we have this NRF dongle, and this can be set up and programmed to intercept Bluetooth low energy connections, and then using Wireshark we can actually listen to and analyze those connections, and we will use that a lot to look at the commands that are sent and some of the data that's sent. And then one other thing that would be super helpful, and I use it a lot, is NRF Connect for mobile. So this just allows you on a mobile device to essentially perform most of the tests we're going to actually be doing on this computer, but you can just have it in a smaller form factor and on your phone. I personally use it to find Bluetooth low energy devices and their MAC addresses. You can also use it for a little bit of recon, because you can connect to those devices and see what handles there are and what they do on the device. So the first thing we need to do is identify our target device, and to do this on Linux it can be a little bit tricky, but I like to use HCI tool. So you need to run it as sudo, and if you run HCI tool you will get an option to run an LE scan, and this stands for low energy scan. So this will help us look for low energy, Bluetooth low energy devices. And when you run this scan, you're going to notice we get a lot of devices, but when we stop the scan, we can see we get the device name, and we know we're going after a Govee device, and we also get the device's MAC address. Now from here, you might want to just write this down, keep it in a text document or something, because we are going to end up using it quite a bit to interact with the device. From here, we can move on to other types of recon, because now we know what device we're actually targeting. So another tool we can use, and I've found a lot of success with it, is actually a tool called BetterCap, and you also need to run this as sudo. This I have installed in a Docker container, and this tool has a wide range of technologies that it can interface with and enumerate and stuff, so it's very useful. But in this example we're going to be looking at the Bluetooth, which should be, you see here, BLE Recon. So we should just be able to turn BLE Recon on, and now we're starting to sniff devices again. And here we can see our device that we saw previously, and from here we could just grab the MAC address and we can do BLE enum and give it the MAC address, and it will attempt to enumerate the device. In this particular device I did not have any success using BetterCap, but maybe we will get it to work now. Yeah, so it's kind of finicky. So I've had it sometimes work, sometimes it doesn't work. For certain devices it works, but when it works it's super helpful because it gives you more of a visual view of what the device has going on. But if this doesn't work, we're going to have to do things manually. And to do things manually, we're going to use GAT tool. So this is a tool that we can use to interface with Bluetooth devices. So if we just run GAT tool TAC I, this opens up an interactive session, and then we can tell it to connect to the device using the MAC address. Now here we type the help command and get some commands. The first thing we want to do is look at like the characteristics, and what you're going to notice is it does occasionally disconnect us, but this is okay because we can just type the connect command again and we'll reconnect. But what we're going to look at is the characteristics, and you'll see here it prints out a bunch of characteristics. Now theoretically we can go through these one by one and look at the handles. So if you see here, we have the handle values and their UUIDs. I like to use the handle values to look at the characteristics. So we'll do char read handle, and then we'll just give it the handle. And sometimes these handles have nothing. This is kind of a tedious part of the Bluetooth hacking. If BetterCap doesn't work, you can just mess around with these and look at these. NRF Connect actually does a better job of showing you these things, so I'd recommend that here, but we are going to use GAT tool later on to actually communicate with the device. So GAT tool is a very important tool and a tool that I've used a lot to hack these devices and gain a ton of information about them. So now that we got some reconnaissance out of the way, we're gonna switch from our Bluetooth adapter to our Bluetooth sniffer. And when you have this device set up, and if you guys want, I can go over a setup for this device because it is a little bit tedious, especially to get it set up with Wireshark. You just want to make sure in your virtual machine that you have this device selected. This way it knows it's going to interact with your virtual machine versus your actual host computer. So then we're going to just start Wireshark. And if we see here, if anyone's familiar with Wireshark, these options up here are not normally in Wireshark. And we also have a device called the NRF sniffer. So what we want to do now is, if we have the GoV device, we want to get the GoV app and we're gonna create an account. I personally use something like TempMail to just create a fake account for testing so they don't get my email or anything. And once we have this account set up, we're gonna wanna go through the pairing process. So we just go to the GoV app, and once we're in there, we will start the pairing process. And if you're already connected to this device, you can just forget the device and repair it, because we're going to look at the Wi-Fi connection and the way that this device connects to the Wi-Fi. Okay, so once we have our GoV device either forgotten or getting ready for pairing, so we would just go into the GoV app, and it will probably notice that you have a device nearby. So I like to just start the sniffer beforehand. If our device is turned on, as you can see right up here, I don't know why it's giving me problems right now, but now we have it set to our GoV MAC address. So now if we were to start the pairing process, we're going to notice some changes here as it starts pairing with our phone. So this is sniffing the pairing process. So when it asks for the device name, we hit done. And now it's going to ask to use Wi-Fi. So for this time, we're going to use Wi-Fi. Later, we're not going to use Wi-Fi, so then we can sniff the Bluetooth commands. So we're just going to put in our Wi-Fi password. And once we do this, as you saw on the screen, a lot of commands went by. So those are usually write commands when you see a lot of data going by, and we're going to filter those in a second. So now that we've successfully connected to our Govee device, you can just ignore this error message if you get it. We're going to start filtering these commands. So as we can see here, there was a write request sent here. We're not really too worried about this write request because we can see the data right in here. But what we want is to filter by this opcode. So we can apply this as a filter and as selected. So now we have all these write requests that are sent from our Govee device to our phone or whatever device you use to connect. So as you can see here, we have some data in here. And if we just click on this data, down here, it shows us what the translated version is. And we can also look over here on the info and see that a lot of these write requests are being sent to handle 35. So that's important for when we want to do a replay attack. We know that we should probably be targeting handle 35. But now if we go through, and you could just use your down arrow to look through these write requests, we're going to notice something interesting on this write request here. So here we see that it says TP-Link 1910. So this is actually the SSID of the router that I'm connected to on my phone. And it's the SSID of the router that the Govee device wants to connect to. So next write request doesn't have much, but here is actually the password sent in plain text. So now we have both the SSID and the password for the Wi-Fi network that this device is on. Bluetooth Low Energy can be encrypted. It should be encrypted. This should not be this easy to obtain credentials like this. The difficulty behind this is you would have to be within Bluetooth range of the device at pairing time, but there's still no reason to even have this risk when the device can just send encrypted communications, and this isn't even an issue then. So next we're going to go look at Bluetooth replay attacks. So we're going to have to remove our device from the Govee app, and we're going to reset it up, but instead of setting up the Wi-Fi, we're actually going to skip that and use Bluetooth only. So now that we've prepped our Govee device once again for the setup, we can just turn off Wi-Fi on our phone or whatever device you're using to just ensure that we don't accidentally connect with Wi-Fi, even though it will prompt you for the Wi-Fi information. But so again, we're just going to go into the Govee app, and we will again select the sniffer and select the Govee device. And once we start pairing, we're going to see similar information as last time once it connects. And now we're just going to get the Wi-Fi settings, and we're just going to hit skip. And we will confirm that skipping is what we want to do. And this way, all this data is being sent through Bluetooth. So maybe we want to send some commands to this device. So one of the things we can do with this device is we can change the calibration on the device. So the device is calibrated at 0, but maybe we want to change it by a few degrees. So what we can do on our end on the app is send calibration info. And as you can see on the Wireshark, we're getting a lot of write request captures. This is for every time I press to increase the calibration. And this actually changes our device from, it was originally at like 75 degrees or 77 degrees, and now it's saying reading at 84 degrees. I'm going to capture a screen recording and a video of the actual device so that we can show what I'm doing, and I'll voice over that later on. But now that we've completed our capture of the commands that we sent, we can get our same filter as last time. So we're going to get our write request filter, and you can just apply it as a filter, and we can see there's a lot more write requests here. And again, a lot of them are getting sent to handle 35. So we can assume somewhere down in here a write request was sent that was used to change the calibration. And what you would do from here is we can just select one of these values here. We can look at it in depth, but we can just select the value, so we can copy the value. Actually, if you just come down here to value, you can just copy the value, and you would just hit copy value. Now from here, we'll open up another terminal, and this is where we use GAT tool again, right? So we have GAT tool, tac I, and then we tell it to connect, and we're going to tell it the MAC address to connect to. So here I just pulled up another terminal in the bottom half of my screen, and here we have my MAC information that I wrote down earlier. So we just give this information to GAT tool, and it can't connect. That's because our phone is currently connected to it. So if our phone's out of Bluetooth range, or we turn off Bluetooth, we will be able to connect. It also helps that I spelled connect wrong, but now this error is because I forgot to switch out to my Wi-Fi adapter. So once we switch to our Bluetooth adapter, once we switch to our Bluetooth adapter, we can connect. So now if we look at the help section again, we can see write command and write requests. And if we look at Wireshark, these were write requests. So we're just going to do exactly what the app did, and we're going to send write requests ourselves. I had researched this previously, so I have some commands here. So these are some of the calibration commands. So I can personally just copy these values, and we'll reconnect to the device. And then once we're connected, we can send the command. And here we can see it says characteristic value was sent successfully. So this changed the temperature a little bit lower, so now it's reading at 80 degrees. And now if I were to send this command, it'll change the temperature higher and read a higher temperature. So now it's reading 81 degrees, which is not a huge jump in temperature, but this is a vulnerability that I've found in other devices, and more concerningly in a device that controls other devices. So it's a device that you would use for agriculture. It would be connected to devices to help automate your farming and like watering of plants and keeping them at the correct temperature and environment. And I was able to not only change the temperature to trigger other devices like maybe I raise the temperature really high when it's actually in winter, and it turns on the cooling system inside of a greenhouse and it kills all the crops. Or maybe I change the humidity and it says it's too humid or not humid enough, and it again kills all the crops. But on top of that, I was able to actually interface directly with the peripheral devices connected to that device through just Bluetooth commands. And with a Bluetooth adapter, you can get an even stronger Bluetooth adapter. You can do this well out of range, and no one would know that you're just destroying their crops or messing with whatever they have going on inside their house. So that's pretty much it for the video today. I'm probably going to also release another video about Bluetooth hacking, and we'll look at another Govee device. We're going to look at Lightstrip, and we're going to make our own little web page for the Lightstrip. But now I'm just going to show the video of the device actually being changed when I send the commands. So here is the Govee device. Right now it says it's reading 75.3, and what we're going to do is we're going to actually change that value. So we're going to connect using GAT tool, as you've seen previously. And now that we're connected, we're just going to take this is the max value for the calibration limit, and we're just going to send this. Oh, it disconnected, so we'll just connect again, and once we connect, we'll send this command, and now we will see it actually changed the value. So it only went up 6 degrees, but depending on the application, 6 degrees could be a lot or maybe not enough. But this was just a quick rundown of how to perform Bluetooth low energy hacking and Bluetooth low energy sniffing and Bluetooth low energy replay attacks. So I hope you have a good one and just stay ethical.